So what's called polar form is a way of using trig functions to represent complex numbers. So complex numbers, remember a plus bi, they could have that imaginary part with them. So we have never graphed imaginary numbers before, but we can if we think of the horizontal or the x-axis being representing the real numbers and the vertical axis representing the imaginary. So instead of thinking of it as x and y, you think of it as real and imaginary. So we could turn around and graph these things. So we are used to seeing numbers, imaginary numbers, in what's called rectangular form, which is just our typical a plus bi. So here are two imaginary numbers in rectangular form. I want to graph those to start with. So if I am graphing them, the x becomes our real axis. The y becomes the imaginary. So if I ask you to graph 6 minus 2i, what's the real number there?
6.
So we go over 6 on the real axis. What's the imaginary number?
2i.
It would actually be negative 2. So the real is 6, the imaginary is negative 2. And these are typically graphed as vectors, so they have an arrow on the end. So this represents 6 minus 2i. So if I have to graph negative 4 minus 3i, my real is negative 4, my imaginary is negative 3. So we go left 4, down 3. The other thing we asked for was the resultant. What that means is, what do you get when you add these things? Okay, so we can think of it as adding vectors, and we can think of it as just adding like terms. So if you take negative 6 minus 2i and add negative 4 minus 3i, what do we get? So to graph the resultant, we would go over 2 and down 5.
And do you want the resultant arrow in a different color?
No, yes. We'll just label which is which, at least on them. So when it asks for the resultant, that's just adding those vectors together. Now, we have seen x, y's, r's, and thetas all throughout trig, right? And we see all of these same things when we are talking about our vectors and our polar form. So keep in mind, a fact that we have used before is if you take x divided by r, which ratio, which trig function is x over r?
I think that's no cosine.
That's cosine.
And then y over r is sine.
So we know this already.
And then y over x is tangent.
Good.
And then if you flip on them, then it's
Good.
secant, cosecant, and cotangent.
Good. So in terms of looking at these, x is r times the cosine of theta. So if we're looking for an x value, we can do r cosine of theta. y is r times the sine of theta. Tangent equals y over x, we kind of used that already when we were finding the direction angle, so we can use that already by itself. The other thing that we've encountered is finding the magnitude, which is just like that horizontal distance, and we know in this case that would be r is the square root of x squared plus y squared. So those are all the things that we've used this semester. We have to now turn around and how to relate them. So let's talk about the actual definition of the polar form. If you think about our graphs, the x was the real part, and the y was the imaginary. Okay, so if I need to relate it to this, the x is like your r cosine of theta, plus the imaginary, which when we graphed it was the y part, right? And since it was imaginary, it had the I with it. So that's like your r sine theta being your y, but then those had the I with them because it was the imaginary. What do both of these terms have? An r. So typically when you see the polar form, it'll be r in front, and then cosine theta plus I sine theta. So this is the definition of polar form. So let's take something in polar form and see if we can rewrite it in rectangular. So polar form has sines and cosines in it. Rectangular is like a plus bi. So if I ask you to put this into rectangular form, we basically just have to work it out. 300 is in which quadrant?
4.
Reference angle? 60. Okay. So we have 2. So the cosine of 300. So in quadrant 4, cosine is positive. What's the cosine of 60? Plus I times. Okay, in quadrant 4, sine is negative. What's the sine of 60?
Square root is -2.
So if we distribute 2 times a half, we get 1. 2's would drop, so minus I radical 3. Or you could write it as radical 3I if you want. So going into rectangular form from polar is pretty simple. We basically evaluate our sine and cosine, distribute that radius through. Going the other way is a little more complicated. So I'm going to probably just write down the steps. I probably won't have time to do an actual example of it today. So it's basically a 3-step process. If you start with rectangular, we first want to sketch a graph of the imaginary number. Okay, that way we know what quadrant we're in. Second step is to find r, or thinking about vectors, that's just like the magnitude of your vector. Third step is to find your angle. And to do that, we use the tangent equals y over x, or just like in the vectors, tangent equals b over a. A's, B's, X's, and Y's, it's the same thing. And we do have to be cautious when we're finding that angle, we have to watch what quadrant we're in, which is why we drew the graph to start. So we're actually almost done with this section already.